So Till Musabowski is a professor of theoretical computer science at the University of Magdeburg, previously at the University of Bremen. I believe you started there, and then the FKI and University of Freiburg, if I'm still correct, and I didn't miss any big step. And your interests are mainly in semantic methods and formal ontologies, neurosymbolic integration, modeling for electrical grids and renewable energies, and finally, qualitative spatial-temporal constraint satisfaction problems. And this makes a little bit of a picture of the competencies and the interest. So one moment, Till. Okay, I said this is the camera. Perfect. Now you have time till 5 o'clock, I believe. So if you can be a little bit shorter, so we have maybe a few minutes for the question. Please go ahead. Please, could you sit? Till?
Yeah, thank you, Stefano, for inviting me, or Claudio invited me, I think, and thank you for the opportunity to speak here. Sorry that I have to leave so soon for some lecture here at the university. So the big picture of interoperability is both for modeling and for ontologies. You have three levels. You have the instances where you have data or individuals. You have terminologies where you have concepts, and you have languages like OWL and first order logic and things like that. And interoperability is actually an issue at all these levels. And here we will focus on the ontology and ontology language level, although there are also big problems in data integration and so on. There's also a lot of interoperability going on there. That would be a third level. And central will be the notion of ontology alignment because this allows to align ontologies and interoperate the ontologies. And Thorsten in the next talk will also bring more conceptual examples of how to align ontologies. I'm more talking about the formal and tool details. So the question is, how do we give semantics to ontology alignments? Can we integrate ontology along alignments in a semantically grounded way, and also across different ontology languages? So here is some alignment example in Manchester syntax and DOL notation. DOL is the distributed ontology language. I will explain this later. So we take the logic OWL serialization Manchester syntax. I should mention that recently a bachelor student of mine has extended Manchester syntax so that it's now covering the full of OWL, so no restrictions anymore. This also has been implemented in the OWL API. And so we have two ontologies, O and P, both have some classes. Here you have some individual, and then we align these ontologies here. So we can have alignments as first-class citizens and say from O to P, there's an alignment. Person is human being. Alex is this individual of O is in the class male of the second ontology P, and child and employee are just disjoint. So the alignment allows for different relations like equality, disjointness, membership can be here possible relations. And a network of ontologies consists of a graph ontologies and alignments. And then you have three different semantics. There's a paper on that for the alignments and their integration. We here focus on the simple semantics. That means a model for such a network consists a model of a model for each ontology over the same domain, such that the individuals are in the relation specified as the alignment specifies. And so that's here some example network where we just take our previous example and organize this in a network. DOL allows just to define a network by just writing the ontologies and the alignment. And then the semantics would be you have a common domain, models for ontologies O and P over that domain such that the alignments are satisfied. And the interesting thing is that we can now combine these ontologies into one by using this combine keyword. And the semantics is given by a co-limit of this network. That's in the sense of category theory. There are some technical details supporting this. That's not important here. We have a mechanism of combining, and we can look at the example here. That would be the combined ontology O and P, and here you see now the disjointness is now no longer a percent as in the alignment syntax, but a disjoint with as in Manchester syntax and so on. So we have reconciled these two ontologies into an integrated one. We can check joint consistency. So either we take this for ontology development, or maybe we don't want to integrate the ontology in real life, but still it might be useful to for tooling to construct this integrated ontology, just to check consistency with standard reasoners and find inconsistencies across these ontologies. And then we could try either to repair the ontologies or maybe to change the alignment such that we have a kind of consistency which is across ontologies, and of course then enhances interoperability if there are no contradictory things. And this is all a semantically grounded way. Yeah, the flattening of this ontology into one of this network is using a bridge ontology. And there are also other semantics. You can have integrated semantics. There you have different domains. They are reconciled in a global domain. That can also be useful. Or contextualized semantics, where these different domains are not even integrated into one big global domain, but they're just related by coherent relations. Also in these cases, you can construct bridge ontologies, and you can flatten these networks into one big ontology, either for using it or for at least checking consistency. And here's some example. We have taken some ontologies from BioPortal, these names here are numeric. We can replace this with enables. Now here you see that there are certain things that even have the same name. Yeah, I think even in all cases, the alignment is along same name principle. So it's the zebrafish and the adult mouse ontology. So it's very easy to align this. And then we have a combined ontology, and then we annotate this. This should be consistent. We can also do this for upper ontologies. For example, here we align Dolce Light and BFO11. And for example, here you would change names. You would say an endurant in Dolce is aligned with independent continuant in BFO, and physical endurant with material entity, physical object with object, and so on. So the first class before the equal sign is from Dolce, and the second one is from BFO. And we also have certain alignments here from Dolce to GFO, where you only have subclass or sub-object property relationships here, as you see by this less sign. And here is a third alignment from BFO to GFO. And then we can combine all these alignments, and then we have one big foundational ontology, where we have integrated everything. Okay. Then there are also a lot of ontology languages that have been used for ontology development. So we can also have ontologies, for example, in OWL, and foundational ontologies are written first order logic, higher order logic, or Deutsch is written in modal logic. So here is a multi-alignment example where we have Castle as first order language. Here we could also use common logic here, which is also a popular ontology language at the first order level. And then we here switch the logic, and then we can also align ontologies in different languages. Okay, this distributed ontology language that I have used here is an OMG standard. And this standard has been developed with inviting a lot of people. We, for example, invited Jérôme Usenat, who is co-authoring the alignment API. So the syntax for the alignment is from there. So it's nothing that we invented in DOL, but it's from the alignment community. We have a complete model theoretic semantics. Here you find a page about DOL, and HEADS is the analysis and proof tool for DOL. You can also try it online. So HEADS is the heterogeneous tool set, and it can compute the flattened ontology and check consistency, but currently only with the single domain semantics. And we have also some examples in DOL here. Okay, I think that's it. So my conclusion is that the semantics of alignment provides the basis for different things, like integrated ontologies can be computed. You can check consistency. You can also compute modules. That's also interesting. Modules are kind of subsets of ontologies that are relevant for a specific purpose. Like in SNOMED, you could say medical ontology, I want just say everything about the heart. Then you get a module about that. And here with an alignment, you could just say, okay, I have an alignment, and now compute me the module for that alignment. That means everything that is involved in this alignment should determine what's in the module. Okay. Yeah, that's already it. So thank you for your attention. Are there any questions? You could also type in questions into the chat, and then I could answer them.
Can you hear me now?
Yeah, yeah.
Okay, sorry that something went wrong. We heard so, okay, now, do we have a question? You have to run away, right? But let's see if there is any question.
So let's again. Unless there are other questions, maybe I can ask you something. I was wondering, do you have any feedback of people that have used the alignment that you described?
No, not yet. Actually, we are just renovating HEADS, and we have put a lot of effort in improving the OWL support. Yeah, because when we worked on these alignments here, yeah, especially this one, there were problems. These are large ontologies, and then there was functional syntax, and we couldn't properly read in functional syntax, or yeah, the Manchester syntax had these problems. That's not complete, and so on. So we put it a lot of effort in. Now we support functional syntax. We have extended Manchester syntax that is covering complete of OWL, and now we can actually redo these alignment experiments. And we are just developing a new GUI for HEADS, because the old GUI is not very useful anymore and outdated and old-fashioned. Now we have a Python binding for HEADS, and with all these new things, I think in the near future we can also redo the alignment stuff and then get some feedback. But currently we have.
I have another question for you. You know that we made recently an alignment between Buffo and Dolce, which is expressed in terms of first-order logic formulas.
Ah, yeah, no, I didn't know. Then we should try to formalize this in DOL and
exactly. That was my point. So maybe it's a bit a heavy document, but we'll discuss how to implement this integration.
Yeah, That would be a good use case for doll and heads. Yeah, great.
Okay, perfect. Thanks a lot, Till.
Yeah, thanks, Stefano.
Bye-bye.
Bye-bye.
And enjoy your lecture.
Yeah, thanks.
And okay, now we move to the second speaker, which is Thorsten Hafmann. And he is at the University of Maine. Previously, he studied in Toronto with Michael Gruninger, the other ontologist we heard during these days. And let me list your topics of interest, at least according to your webpage, and then you may add something more if you want. So it's spatial informatics and spatial ontologies, complex and heterogeneous information systems, automated reasoning on ontologies, geographic, geological, hydrological, and environmental maps. And you made a name on those topics. So if you want to add something more, otherwise you can start your presentation, Thorsten.
Thank you, Stefano, for the introduction. Yeah, the website is quite outdated. So more recently, I've actually kind of moved a little bit more towards kind of domain ontologies for kind of supporting large knowledge graphs, and in particular for like forestry, material science like cellulose, and more recently also PFAS like chemicals and contamination. So it's pretty broad, but it's still drawing on a lot of the early work on kind of spatial data integration. Yeah, thank you for inviting me here. And so I wanted to talk a little bit about kind of what Till already touched upon, the different kinds of ontology alignments, or semantic alignment, and then particularly talk about an approach that we've been using called domain reference ontologies and how that works. So just to briefly give kind of an overview, what is semantic alignment? Till already mentioned that there are various different levels of alignment. So it can be with or without existing ontologies. We are particularly looking here at what's typically called the ontology alignment. So where we're taking two ontologies and want to align them to one another. But even that kind of brings up a lot of issues because the differences between the ontologies can be at various levels. So syntactic, like what the how are things represented? That ranges from just using different labels, different encodings. Then we have differences in expressivity, like the things that Till already talked about, and also differences in modeling approach. I won't get into those. But then we have kind of more conceptual differences as well. Like, what are the ontological assumptions that people make? So, for example, are locations always points, or do we allow like polygons or regions as locations? And then there are differences in scope and or coverage. Like, so one of the domains I've been working on was hydro-ontologies, and every hydro-ontology has a slightly different scope. There's some that focus on groundwater, others on surface water, some on kind of the very specific geometry of, let's say, a river, others more on just the location and the shape or the network. So there's a lot of kind of minor differences that don't jump out right away when you kind of look for ontologies. And similarly, we have differences in granularity. Some ontologies might be more high level. Others might make very specific distinctions between different kind of concepts. I have an example here. Like a classification of lakes could be by geology, and then another one by kind of productivity, so more taking an ecological perspective. And those are very difficult to integrate, if at all. But the larger issue is actually often we don't even know which differences we are facing. We kind of have to look at the ontologies you want to align carefully to kind of figure that out. We cannot just take a cursory look, see something like a river and a stream, and conclude, oh, they're the same. It really depends. Like, what is the scope of the ontology? What it is used for or designed for? Are there any like definitions included, or are they just natural language definitions? Are they axiomatic definitions? And so all of this together has kind of led me to the conclusion that if you want to do it correctly with kind of expressive ontologies, ontology mapping is just as difficult as developing new ontologies, which is kind of not what most people want to hear, but it's, I think, the sad truth. So we have to be very careful how we spend our kind of energy on which ontologies do we want to align and where it's not worth it. So, of course, the effort also depends on kind of what's at stake. If you just want kind of a very loose, rough alignment where some kind of imprecision or vagueness is allowed, like if you want to align ontologies for kind of a keyword-based search engine, for example, then that's probably good enough. Like, you're not reliant on very precise definition. But if you want to do reasoning, ontological reasoning, it becomes much more important. So it really depends on what's the question. What do you want to share? Do you want to share just terms? Do you want to share instances? Do you want to actually know what assumptions, what commitments are kind of preserved? And this kind of brings me to this kind of point of what do we want to preserve by mapping? So the one thing that Till mentioned is primarily kind of the terms or concept that we are mapping. And even there's a difference. Like we might have different terms for the same concept or the same term for different concepts. So we cannot just lump them together. But if you want to share like inferences, you really need kind of a alignment that uses a logical definition of the of concepts or relations from one in terms of the others. If you do just individuals that you want to map, then you can kind of do that without the axioms by kind of just essentially doing a set-based approach, like saying that all of the individuals of all of this class are also members of this other class. So to just give you an example from the hydro-ontology that we worked on a little bit ago, there are various ontologies there, and they all differ in kind of the generality, scope, and their format. And so there we were looking like, how can we actually align these better? And so one very specific example is like the concept of what's called an aquifer. Like different ontologies have similar definitions, but there are still nuances in there? Like, is it something that always has to have water in there, or is it just kind of a geological, like a rock formation, where is there a functional aspect, like in the NWIS, that supplies water to wells? So all of these things are typically not formalized in these ontologies. So if we integrate them, we could just establish a mapping, oh, this is equivalent, but then we're kind of glossing over these differences in intent. And so that's where we kind of develop this approach using what we call a domain reference ontology for ontology mapping, to kind of analyze different ontologies and integrate them with the reference ontology. So let me explain just a little bit what we mean by a domain reference ontology. You can think of it kind of like a foundational top-level ontologies for its own domain. So we were working specifically on a domain reference ontology for the hydrology domain. So so it's kind of in between foundational top-level ontologies and specific domain ontology. And what we found helpful is for a domain reference ontology to kind of limit the number of terms, just a very few terms, but axiomatize them in detail and then use those terms and axioms and relations to kind of define the differences, or like what each concept in each domain ontology means. So let me actually skip this. So here's just a figure how we kind of envision or think of domain reference ontology in the overall landscape. So we have the foundational ontologies at the very top, and then we have kind of this middle layer that we kind of broke down into the domain ontologies, domain reference ontologies, and generic ontologies, which are about kind of cross-domain aspects that are more specific than what you would find in most foundational ontologies. And so there's some interaction between them, but the idea is to abstract kind of the domain ontologies to kind of a reference element in that particular domain that's integrated with the foundational level. So when you map a new domain ontology, you don't actually have to use the foundational ontology. You can just use the domain reference ontology. And that's typically more accessible to domain experts, like that don't know about the difference between endurance and perdurance, for example. So how is that useful for ontology mapping? So the use case, the test case that we worked on was mapping GWML to a domain reference ontology. So we have here's some concept from GWML, and there isn't a whole lot of, in terms of definition, like axioms in GWML. It's mostly kind of cardinality constraints and subclass relationships that are provided. But we kind of use these concepts to align them to the domain reference ontology to kind of identify which reference domain concept is the generalization of specific concepts here. And those, in turn, are aligned with the upper level, the top level ontology. So this alignment only needs to be done once, and that's kind of where the somebody familiar with top level ontologies is needed. And then the alignment between GWML2 and HIFO is something where we really need involvement of domain experts that understand what this domain ontology aims to capture, even if it's potentially not actually written down. And then when we do the same thing, I just kind of give some examples here with another domain ontology, like HY features, for example, that covers surface water concept. Then we kind of have an implicit alignment that says, oh, the hydrologic units in surface water in the surface water ontologies is similar to the hydrogeo unit. It still is not at the level of, we cannot say that these are equivalent, but we at least know they are kind of specializations of the same generic concept. And that is as far as we go with these alignments here. So for this particular ontology, just to kind of give you a taste of what the HIFO actually looks like that we used for the alignment, it has like these four concepts. We added a fifth one later on and kind of relationship between them. And that is actually enough to define most of the concept in GWML2. So just an example, so the aquifer concept in GWML2 is then kind of defined using specific axiom names, things like it's a subclass of a hydrogeo unit. It contains some solid body, and here we have the axioms underneath that actually capture that in more detail. It's constituted of some earth matter and contains this one and is hosts some void named the spaces where the water can be, and the void may contain an aquifer water body. So this just for one concept, there's quite a lot of going on here. So if we pull this all together, we actually get a full definition of an aquifer, of a GWML aquifer in terms of HIFO. But as you can see, this is not like something that's established automatically in any easy way. This requires kind of in-depth ontological analysis, and that's done primarily in a manual way. So it's not very scalable, but it actually achieves the kind of highest level of the most precise alignment that's possible in such a kind of complicated, nuanced case. Thank you, and happy to address any questions.
So do we have questions? Chris? Who wants to start? Francesco, it's better you come here.
Thanks for the talk. Can you elaborate a bit more on the role of the strong axiomatization in domain reference ontologies?
Sorry, can you elaborate?
A bit more on the role of the strong axiomatization in domain reference ontologies.
The role of the axiomatization?
Yeah, you specified that you want to have a stronger axiomatization, like if it was a foundational ontology. So if you could say a bit more on.
Oh, okay. So you mean like how the domain reference ontology is kind of axiomatized in the first place?
Maybe if I can add, there is a context here, meaning we had a discussion earlier And there are people claiming that axiomatization in first-order logic could actually damage interoperability. And so the question here is, well, in your experience in domain ontology, do you find it useful you're having a strong axiomatization? If I interpreted the correct, otherwise you can add.
Okay, yeah. I see. I understand now. So I think in our case, I think if we've just done like with a kind of a weaker axiomatization, we would just have had kind of the subclass alignments, and we wouldn't actually have been able to elicit kind of these differences about kind of what is necessary for, let's say, an aquifer. So the differences between is the water part of it or not? Yeah, it's very hard to tell. I mean, a lot of the things you could probably do in OWL, but you're doing it also axiomatically. So if you get rid of all the axioms, like the axioms that actually involve some quantification, let me qualify this, then you don't really see how the differences, whether there are any differences, because then you're really just getting things like, okay, the GWML aquifer is a subclass of a hydro rock body, and this other one from another ontology is also, and then we don't know whether that's actually compatible or not. But I think the question kind of extends also, if you don't actually have axioms at the level of the domain reference ontology, like the detailed axioms, we couldn't have defined like differences between, let's say, a hydro rock body and a water body. That would have just collapsed in some way. Like that there's no difference obvious anymore.
Is that enough, Francesco? Okay. Chris?
Torsten, I really like that. I really like the amount that you dragged out of your example. But I have a series of general questions. So
wait a moment first. Can you hear, Torsten?
Barely.
Okay, come here, please.
Shall I not say I liked it again? I've said that once, yeah?
Say again?
I'm joking.
Oh, you're joking.
Okay. Torsten, I really liked it. I think what the amount of information that you dragged out of the example and the way you dragged out of it, I think is really good. But there's a series of things that watching you do this that I wonder about. So Till talked about the different levels. He had these 3 levels, and the 3rd level was instances. And I'm reading you as you didn't include instances in here.
Yes, in this particular case, because there actually isn't any instance data for all these.
Okay, so
most of these hydro ontologies.
Yes, that was, in fact, you've almost answered my second question, because I was going to say is I imagine that it's probably quite difficult to get hold of the instances. So you were in a stage, and yeah, okay. The other thing that I worry about is, and this is, again, there's a context to this. You're using you're using predicates to contain semantics. You're not doing what Barry does, which is putting all of the predicates into the domain and running like that, because I presume the provers won't work in quite the way you want. Is that right? Or have you considered doing anything like that in order to, when you run the theory? Do I need to explain more, or?
Yes, I think so. I didn't quite understand the difference.
So you've got a predicate, I forget, let's say body of water, and that's going to be, in FA, F's going to be a body of water. I'm suggesting what happens if the constant A was body and water, and you had a relation in the domain which was is an instance of, because I think that's the way Barry does. You haven't considered doing anything of that and trying to think about how that impacts the mapping. The reason I'm wondering is that if you have these two different structures, such radically different structures, the mapping, I'm intrigued about the pressure it'll put on the way you do the mapping, because you said, the same number of objects there. I mean, you raised that in your thing, didn't you? Your Claudio and yours, you had the same problem, yeah?
Mm-hmm.
Yeah. I'm just wondering whether Torsten.
Yeah, I think that's kind of more at the level of the modeling approach, like differences in modeling approach, because we really treat the instances as kind of in a first order way as objects in the domain, and there is no separate instance of relationship.
Yeah.
But if you model that, it becomes like a whole different approach, because then you have that as part of your relation, and we couldn't really map that here in a first order way. I don't know how you would do that.
So that would increase if you had one doing it one way and one doing it the other, that would increase the complexity of the mapping relation.
Yeah, because it's then really like a mapping between the modeling approaches.
But isn't it? It's a mapping between. They've got the same. That you could say they've got you could cache them out with a very similar ontological commitment or semantics or whatever you want to call it. Maybe not a logical model. I'm not a logician, so it's definitely. But in a sense, at some level, there is a intuitive mapping between them. It's just I would say syntactically. Is that fair? Syntactically or some way in modeling language, you've modeled the same thing in a different way. No.
Apparently, you have the same information inside, but it's coded differently.
Yes. That's right. Yeah. Okay, but it was. I really liked the stuff. I think it was really good the way you drag this the differences out.
Thank you.
Okay. Do we have other questions? I think no. We are done. And I apologize for this. Camera comes from the 80s, probably. But that's the best we got. Thank you, Torsten. And now
I see some shadows.
Now we have Riccardo Pigazzi. He's presenting live here in person, Flesh and Bones. Riccardo Pigazzi, he's a PhD candidate at the Politecnico di Milano in mechanical engineering. Yes. And he's interested in methods and tools for the design and production of heterogeneous objects. And he has been working, the motivation came from additive manufacturing, and he has been playing with the modeling of qualities, starting from Dolce, but the point there was to see, okay, what are the alternatives of modeling qualities, being coherent with that approach, and then the idea is to see what are the interests, okay, the differences and the interest that you can have in taking one approach or the other one. So it's now showing these models. Okay, Riccardo, please.
Okay. So this work deals with design pattern to represent engineering qualities and values in OWL. The use of ontology is ontologies are gaining popularity in engineering application as a conceptual tool for sharing information and knowledge between expert and software systems, and to make explicit non-digitalized information and tacit knowledge that exists in the mind of experts. Starting from a foundational ontology is in general considered a good practice to improve the quality of the domain ontology and to promote its interoperability with other domain ontology. However, the adoption of foundational ontology in engineering is not widespread because foundational ontology are very general, and engineers have to make effort to use it. Just to make an example of how foundational ontology can be used in engineering application, I briefly report my research work. So my research work deals with the design and production of heterogeneous objects, which are objects specifically designed to exhibit a variation of material composition in order to achieve a corresponding variation of material properties. And the technology that I have considered is material jetting, which is based on the deposition of liquid droplets of liquid photopolymers, which are cured by UV light. And in this context, these solidified droplets are called voxels, which are volumetric pixels. In the context of this work, the foundational ontology has helped to distinguish the portion of material deposited from the voxel, and to disambiguate different meaning of voxels. For example, as a virtual feature of the object as designed, or as a physical feature of the object as produced, or again, as a feature of the printer, understood as a location where to deposit material. And also the foundational ontology, in particular Dolce, has helped to manage in an integrated way the qualities of the objects. For example, the size of the voxel, the material properties, and the printing parameters. In this work, I concentrate on this second aspect, and in particular, I investigate how foundational ontology can be enriched to improve its suitability for engineering by proposing some design pattern to support clean ontological modeling of qualities and values in OWL. So just to fix the terminology and the notation, in OWL we have 4 different kind of logical expression to denote things. Individual denote single objects, class denotes set of objects, object property, binary relation between object, and data properties, binary relation between an object and a data. So the question is how to model qualities or attributes of the objects, like length, mass, color, shape. And a straightforward approach can be to represent qualities directly as data properties that directly link the object which bear the quality with the literals. However, this approach requires to introduce a different data properties for each kind of qualities. And if we consider also the unit of measure, the number of qualities increase further. And also, if we consider that the same quality can have different values and different time, we have to introduce also the time. And what about qualitative values for which the data property are not the most suitable construct? So briefly, the ontology become cumbersome, difficult to keep consistent, and to integrate with other application and data sources. So if we look at the Dolce taxonomy, we can see that qualities and values are considered as object in the domain of quantification, like the object that have these qualities. In particular, Dolce is based on, so the idea of Dolce is that endurant and perdurant, which are entities that exist in time or happen in time, comes with a set of qualities which inherit to them with the relation of direct quality, and this quality takes a value in a region of a quality space through the quale relation, which can be a simple object properties if it is binary, or a reified ternary relation if it involves time. Specifically, Dolce is based on the notion of quality type, individual quality, quality region, and quality space. So by taking as an example the quality of diameter, the diameter is the quality type, whose instances are the individual qualities that inherit to the individual objects. And besides each quality types, there is a corresponding class of region, whose instances are the quality space used to measure the individual quality, together with the region that make up the space. The quale relation is represented as a reified ternary relation, provide the location between the location of the individual quality in a region of the quality space. And most of the qualities of engineering interest can be evaluated in both a qualitative and a quantitative way. For example, we can say that the diameter is small, medium, or large, or we can use a value with a unit of measure. And both the aspects can be considered in the same ontology by introducing two different spaces. And this is useful because we can assess the same quality in different way. However, if the quality value can be considered as directly as regions of quality spaces, for the quantitative value, there are different modeling possibilities. In fact, the magnitude of the value can be introduced, for example, with a data property. However, we can associate a unit of measure in the range of the data property. In particular, we have to decide how to consider two values, such as 10 millimeters and 0.394 inches, which are the same quantity. And analyzing the relation between values and the quality space of Dolce, we have three different alternatives. The first one is to consider both the value as the same region of a certain quality space. The second option is to consider the two values as two different regions of two quality spaces. Or we can consider the values as additional individual other objects other than the regions. So in the first case, we have to qualify the data property with the unit of measure used, while in the second and in the third option, because we have two different individuals, we can use a single data properties and an object property as unit of measure if we introduce explicitly the unit of measure in the domain of quantification. Here, the class unit of measure is considered in the taxonomy of Dolce as a subclass of non-agentive social objects. And if we look how the alternatives interact with the rest of the ontology, we can see that the first option is the more parsimonious in the terms of individuals and require also the introduction of a set of data properties qualified with the unit of measure. However, as the limitation discussed at the beginning, such as the introduction of different kind of data property for a unit of measure. And also the query can be done with the specific unit of measure. In the second option is quite straightforward from a modeling perspective, but it requires to introduce a different quality space for each unit of measure. And this in general can be considered a bit strong. And we can also see that considering the two values as the two regions of two quality space require to use two different quale relations, because being ray-fi ternary relation, the free object properties are functional. Finally, the third option, like the first one, require only one quale relation, and there is only one region, but increase the path from the object, further the path from the object to the data value. I can also say that in this case, the values are considered as abstract objects with the aim of associate the same value to different region of different quality space. But if we consider these values simply as a ray-fi ternary relation, we have to put the value class under the class of the ray-fi ternary relation of Dolce. And in this case, we have a different individual for each triple constituted by a region, a value, and a unit of measure. In summary, these are the three options. The first one requires just the introduction of a set of data properties. The second, the introduction of the class unit of measure and an object property as unit of measure and a data property such as data value. And the third option, also the introduction of the class of value. And if we compare the three options with two well-known ontology for unit of measure, ontology of unit of measure and quantities, unit, dimension, and data type, we can see that in these ontologies, the values are considered as individual with an associated unit of measure and literal. So if we want to import this ontology in Dolce, these can be easily aligned only with the second and the third option. In the second one, the values, that is called measure and quantity value, are subclasses of regions, while in the third option, they are subclasses of values, or even equivalent to the class of value. These are just three examples of query for the diameter of the object at a given time to show that with the first option, we need to ask a query with the unit of measure used, while in the second and the third option, we can ask a generic query and having return all the value with the associated unit of measure. And to conclude, the value discussed are associated to the atomic region of Dolce, which are a region that has no proper part. And if we introduce a relation of precedence between this atomic region, which can be inferred from the numeric value associated to that region, we can write some rules to infer all the different relation between intervals that have been introduced in the context of time intervals. And as a future work, this relation can be used to introduce also the concept of tolerance to the qualities of the objects. And that's all. Thank you for your attention.
Okay, thank you, Riccardo. Do we have any question?
If I may, I have a question.
First thing, please.
So I've also been kind of struggling with how to represent kind of qualities in kind of different domains, like qualities of chemicals, of materials, etc., in forestry. And I don't know what your experience is with kind of navigating the need to be pragmatic versus ontologically rigorous. Because if you follow like kind of a very ontologically rigorous approach, just I found in our case the amount of data, like how much we need to store, just explodes, which triggered us to kind of use shortcuts that are not very ontologically rigorous. I don't know whether you have any thoughts on this.
I don't know if I had understood correctly the question, but I mean, your question is about the trade-off between being ontologically correct. It's correct. And
yeah, like what you kind of showed here, like the distinction between qualities, quality kinds, quality spaces.
Okay.
It all makes sense to us, but if you want to actually encode all that data, you have so much data that it becomes unmanageable. Because every instance, every measurement is actually kind of becomes like, rather than one triple, it becomes like 20 triples.
Yes, this is true. So if we want to maintain the number of individual small, we have to qualify the different data property with a lot of qualification. However, this approach is, in my opinion, is difficult to be general. It works only for a small application, and so it doesn't promote the interoperability with the ontology with other ontologies.
Okay.
Okay.
Now, in order, Chris.
May I just have a comment on something that Torsten asked? Oh,
yeah, sorry.
No.
So, Torsten, we found exactly the same problem, but the solution is different. I think the solution is not to give up, it's to go for a different implementation. So you're being asked, basically the machine is telling you that you're not doing it the right way, your implementation is wrong. Well, okay, if you shouldn't let a machine tell you how to do your ontology. You're in charge, not the machine. And at least that's the approach that we've adopted when we get this explosion. And you definitely do get an explosion. And I was going to ask you a question like Torsten about, is your data, do you have data types on your data? So but your data is a numeral, not a number. So if you considered trying to put numbers, which would give an even bigger explosion, or is that not the Dolce way of doing things?
We don't do difference between number and numerals.
Okay. But you don't have the notion of a number. There's not a space.
We have under the abstract in the original version there are numbers.
Yeah, then the numeral could just be the name of the number. Yeah, so you have another layer.
You're again in the abstract domain,
Yes,
and there you can multiply very easily whatever.
I told you the other day.
I understand the problem.
Yes.
But the values that I introduced in the third option,
Yeah.
these are
would that be
number with
okay.
Unit of measure associated.
Okay, and then it's not a.
In the second option, these values are the regions.
Magnificent.
Of
that's really good. Thank you.
okay.
Please.
So first, I really like your presentation. So my question is, you are storing actually all the, if you have a large domain with a lot of relation, you're storing all the values in the ontology. So my question is, what is the purpose of the ontology? Is it to keep all the values if it's a large system you're describing? Because I have another process.
I take a step back. So the first aim of this work was as engineering, we want to use an ontology, a foundational ontology. So the first thing that we want to store is a value. And looking at the documentation of foundational ontology, it wasn't clear how to store a simple value like 10 millimeters. So I tried these different options with the aim of say what is the best option for the adoption of a foundational ontology in this context.
Yeah.
Then, for a practical application, I think to store only the values that I need.
Yeah, I think it's just. I think the approach we have been using is that if you have a lot of value, so we store them separate from the ontology and use the ontology for describing our data. It provides a document our data, but it's not. We do not put the data into or put all the actual numbers into the knowledge base.
Okay.
So the knowledge base is just describing the data sets, where you can find them, and what are, if you have a huge say spreadsheet, what does this column mean? What is the unit and so on? You can, that is
the instances are stored in another.
Exactly, that can be in a database that is more suited for huge amount of data. What kind of, that can be object store, it can be a relational database, if it's table, it depends.
This is the interest also for my application, because voxels, I have to deal with voxels.
Exactly.
And there are billions of voxels. Also, if we make this distinction between physical and virtual voxel, the number is also double.
Right.
So the ontology in this case has to help people to understand the different meaning of voxel.
Exactly. That's
but
at
we
least
can
how we are using
instantiate the ontology with all the voxels.
Yeah. Yeah, thank you very much.
Yes, I would go in this direction of Jasper. Ontologies, OWL is for metadata, not for data. If you are an engineer and you work with data, you don't work with scalars. You work with matrices, vectors, and we know that there is no way to store this data structure in OWL. Well, you can, but you would be crazy with that. And QUDT, this is the original sin, in my opinion, of using OWL for storing the emitter. You should not store the emitter unless this is a metadata for a particular object. So for example, the dimension of furniture in the IKEA. So it's in a catalog. Okay, but if it is a scientific measurement for a set of experiments, don't do that. That's wrong. These are not metadata. These are data, and you should not store them. And QUDT, I think, is continue the sin of the father. QUDT is a way to handle unit of measurement, but it should be done. So if you don't know what is the unit of measurement of your data, and you cannot infer this from the data, from the format in which you store your data, you are a bad data manager, really bad data manager. If you do that, so you should not ask an ontology what is the unit of measurement of that particular data set. The implementation that is retrieving this data set should be able to infer this and to do the calculation. Also using like in QUDT, using an ontology to have the conversion factor to move from inch to meter. This is in QUDT. This is crazy. Yes. Okay, we just did this in the MMO a week ago. We just implemented it because that's what the people want. But to me, it's craziness. This is not what an ontology is designed for. At least not in OWL. This is for metadata only. Maybe you can store them in, yeah. So that's my opinion. That's my opinion. You should think of ontology as a way to store metadata and to store the location where the data can be retrieved. So,
but you do not see the unit of measure as a metadata, because you could.
Yes, it may be, but metadata is refers to. It should refer to more to the key box. It's a metadata for a class of chair, a class of sofa, and so on, but not to specific individuals that are generated from experiment or measurement or whatever. So this is something that I'm starting to realize, because also as a programmer, I usually tend to think how as a way as a programming language. It is not. It is not. So using how to store vectors, using how to apply conversion, I think it's wrong. That's wrong. You should use a more efficient solution for the bulk, for storing the bulk of your data, and not to waste time to find how to store a single data coming from measurement. That's my opinion.
Arco, please. You better come here, otherwise we don't.
Oh my God, it's like, oh, poor you, like, it's like big example. Like, so, will you please like bring out, because I have to see the like the Dolce parlance kind of. So if you go to the like the model slide, no, the other one, yeah, it will do something like that.
This
So
is the general part.
yeah. The first question was like I was also playing with this, so I wanted to know this. So the unit of measure, like if you can measure something by a centimeter scale or like millimeter scale, right?
Yes.
Like, why cannot we say that they are two different regions? We can say they are two different regions, but they are isomorphic to each other because they can have like conversion. But then why cannot we say like there has to be a single region by where the particular whale will be located? Yeah.
So two different regions, 4 centimeter.
Yeah. So say I have one coil, like you have like one individual. So quality.
This is the quality relation.
Yeah. So quality relation, which is a particular coil, but then it is in a region, right? In a physical region, you say. But then is it physical? I don't know. But then it is in a region, right?
Okay.
But then can we say like there are two different physical region, one for centimeter scale, one for millimeter scale?
We go to the second option.
Okay. Yeah, sorry, that is exactly what I saw. Like, yeah, that will be. But then this is where like.
So my approach is a bit practical. I want to propose this pattern. I need to use it.
Exactly.
So I try to investigate the different possibilities.
Yeah, so you can actually have two different regions, as you were saying.
See,
Perfect.
in this case, we have different.
Do you agree with this second option?
They are compatible. That's all I care about.
Yeah, they are. I mean, all are compatible. But
Yes,
then
but
I remember
from,
that when I mentioned it, audio kind of resisted. He said like, so this is the thing. Like this says like that there is only one region. As I know, like there is what I was told. Like it cannot be like two regions. There's always one region.
okay.
And then if we're thinking about unit of measure, then we have to think about something which is probably your third option, like think about a non-agentive social object, and then have like a different scale. But then here, I have a different question, but I'm not going there yet. But I do not know. Like if you agree the second option works and Dolce people kind of agrees, I'll be very happy. And that's what I'm saying.
So there is no guideline from Dolce on this. That's why I said it would be nice to present the different options in the audience here, because here there are people working with data. We do not have direct experience with data.
This is a very good I tried with it. This is a really good option. We have to say that these different regions are like, I mean, isomorphic to each other. I think most of the units are isomorphic. I do not know one unit which is like only can be converted one direction, other direction it cannot. But if it is like that, this is good. This is really good. I mean, I believe. But then I do not know. Like if it's like
maybe it may seem counterintuitive to change the units of measure and changing the quality space for some people.
Can be.
Can be.
But yeah, but intuitively, like it is good. The second question was, okay, for the third
We must be short.
Yeah, okay. So the non-agentive social object, you have like the unit of measure, right?
Yes, non-agentive is here.
Yeah.
With the idea is that the unit of measure
so my question was
by a community of agents.
Yeah. So my question was like, can we only talk about 10 millimeter without saying what it is 10 millimeter of? Does 10 millimeter has any semantic? If we do not say what that 10 millimeter is of?
Okay, so I don't indulge it well enough. It's a distance. I mean, you might be using it for a diameter. Is this the problem? Because I just noticed you've got a diameter region, but you could have a length. And presumably it's the same 10 millimeter. Yeah?
Yes, this is another question, another doubt about the structure of Dolce. If these are all different kind of qualities that bring to different quality space.
Okay, it's like I am asking the same question in another word, probably.
But there is actually, interesting, I think there is something that if you say it's a circle with diameter 10 millimeter, then it's different from the length 10 millimeter, but it has a radius, which is the length 10 millimeter. So you could run it, you could say the name for a circle with diameter 10 millimeter is 10 millimeter if you want to, as a weird name.
That's a way of speaking. That's a way of speaking. It's not an ontological.
I think it is. Okay. Oh, I see. Okay.
Yeah.
The naming is subjective.
I need to stop you, and please talk with Ricardo, since I see a lot of interest here. Now, we move back to the auditorium for the closure. Tomorrow we have the day devoted to industry, or something related to industry. You will discover tomorrow, and we start at 9:30. Okay? Much better. So tonight we can go out and have fun. Okay, thanks everybody. Thanks Torsten, and everybody else. Thank you.
Thank you.
Okay, bye-bye.
Bye.